Hey, folks, I'm Abhishek, and I think the person who spoke earlier was Nan. Just thumbs up if you are able to hear my voice.
Basically, it's not clear. It's some, background noise is there. I mean, when you speak.
Okay. Just a second. So, yeah, I'm actually out, but yeah, let me try out something.
I think we'll start in another minute. Hello, everyone. Can you hear me? Okay, so I think let's get started. Good afternoon, everyone. Gokul, just mic check. Are you able to hear me?
Yes, Nayan, we are able to hear you.
Yeah, thanks. Okay, so good afternoon, everyone. Let's get started. So today, my name is Nayan Mujode. I'm a co-organizer at a Swift Bengaluru meetup. This is our today's agenda. So, we'll start with our first technical talk. In today's agenda, we have only one tech talk followed by a, EMA. For AMA stands for, ask me anything around, Swift UI and UiKit. We have a good panel. So I would like to welcome Sabapathy for his first talk. Sabapathy is basically, also organizer at Swift Bangalore, and he's a senior software engineer. He has a, very much, very passionate about the Swift, and he wants to talk about, Swift concurrency, Swift 6 concurrency. Sabapathy, over to you.
Thank you, Nayan.
Let me stop sharing. Okay, you can share.
I hope my screen is visible.
Yes, yes.
And I'm audible. So yeah, thank you. Good afternoon, everyone. And I would like to thank Swift Bengaluru team to giving me opportunity to speak on this topic. So I will be speaking on the topic is Guide to Concurrency, Swift 6. And before starting, I would like to introduce myself. I am Kanagasabapathy, and you can call me Sabha. And I'm senior iOS engineer, and I have been working on Apple platforms developer since 2014, and I have good experience in Swift, WDC, and now SwiftUI. And also, I'm specialized in concurrency and also Swift package management. I have done applications which are related in different domains, banking domain and e-commerce and social learning. So this is my brief introduction of myself. Thank you. And so before entering to Swift concurrency, we need to prepare to say a goodbye to first. There are few things like callback help. This we obviously go with the nested closures that leads to unreadable and difficult to maintain the code. And we have error handling headaches also. So there are some complex error propagation with callbacks or completion handlers. And thread safety issues like old way, we have a manual thread management that prone to race conditions and bugs. And complicated synchronization like even though we have introduced with the Swift dispatch groups, semaphores, and other complex logic to coordinate those things. And followed with complicated synchronization and also unreadable asynchronous code that's hard to follow. Deeply nested code parts are there. So thanks to Swift 5.5 and now enhanced in Swift 6. So Embrace is all about wholeheartedly adapting and integrating the new tools and techniques. First is async await. Simple and clean. We can able to write an async code that reads like a synchronous code. and it's a better alternate to nested closures. And structured concurrency, that is a task management. We can able to manage a task life cycle and also ensures that tasks are properly completed or cancelled. And followed with actor isolation. So prevents the data race by isolating state and only one task as a mutable state at a time. And task, that is a building blocks of concurrency. So we can able to create, manage, and also cancel async operation easily, and no need of manual thread management. Cleaner code, you might have seen in async await, we have a cleaner code and also structured concurrency. We can able to understand easily. And in Swift 6, we have a strict concurrency. So that enhance the capabilities, introducing the stricter concurrency checks so that we can avoid the data race. So we'll be looking into in depth in following slides. Yeah, so this is the evolution of concurrency APIs. And here NS thread, I think Objective-C developers can relate the NS thread, and now in Swift we have thread. So that is a manual thread management. And then we have been introduced with GCD, Grand Central Dispatch, and Operation Queues, and followed with the combine that we were depending on the RX script, and now Apple has introduced combine on Swift 5. And then in 5.5, we have got the async await and structure concurrency. And now complete concurrency by default, and also data race safety. So this is the roadmap I have, concurrency roadmap. So I'll be discussing about the features, the version history, and followed with the pros and cons, and also practical examples. For the following topics like async await, structure concurrency, task, actors, and sendable. So we will be diving into async await first. So async await is the basic synthetic building block. So here we have a suspension points. So whenever we are marking async functions, so that enables use the suspension points within the function. Awaiting keyword that introduce the suspension point where function pauses until the asynchronous operation completes. So it will wait for the response, and it will not wait more than once we receive, we will be able to get the response immediately. And here in error handling, when compared to the callbacks, we have a better error handling with the do try catch, where we can able to handle errors easily in the asynchronous function. And this is the function. This is a flow diagram. You can see we use the async method, and data from the URL, it will be calling in through await keyword. So the suspension point will be there. For this flow, it can be done by one task, and while resuming, when we get the response, that can be taken by another task. So this is the specialty of this async await. And here async await practical examples. So you can see the perform task in an asynchronous way. So this is a simple code, and you can see the do try catch. We can able to catch the errors, and also await the certain functions. And this is the example I have used in my network kit, Swift package manager. So here you can able to see the generic way of representing async await along with the networking example. And so here we can able to get the status code in the godlet, and also God statements, and we can also track about the data and the decode error. So these are the ways we can able to achieve using the async await. And the pros and cons, actually this async await that helps in simplifying the asynchronous programming. It was introduced in iOS 15, and in Swift 5.5 it was introduced, and you can see the proposal AC0296. And now in Swift 6 there is a continued improvements also, and also complementary use with GCD, other operation queues, and also combined framework. It helps in the readability, error handling, and also it is a perfect alternative to the closures, and it will avoid the callback hell as well. And there are some disadvantages like backward compatibility and some complex integrations. So this is the one we can say no to callback hell, and we can go with the async await. And then tasks are a fundamental unit of the concurrent work, and it's a sequential, asynchronous, and self-contained. So we can have a group of tasks we can we have done in dispatch groups earlier. And also we can prioritize easily with the user initiated a high, low, and background that could optimize the performance. And it has an inbuilt cancellation one. So this is an example where we can able to set a priority for the task. It starts with the high and low, and also background is the last. And this is the example where I have used for QoS, quality of services, and followed with you can see the multiple task with the help of the task group, and also we can throw task group like throw error by using the throwing the task group. So this helps in the structured way of concurrency. And here it's we have an inbuilt task cancellation. You can see in earlier days we need to go with the manual thread management. So here it is automatically handled. And these are the pros and cons. It hasn't been introduced in 5.5, similarly to async await, and it has a built-in cancellation, and it works well with the async await, and also reducing some concurrency issues such as thread explosion and everything. And we can the disadvantages like when we manage multiple tasks at the same time, because that we are not sure about, and we can't control. That is the disadvantages of here. So this is a good example, and you can see the code is suspended and a thread is unblocked to allow other thread to proceed with some other works. So if you see in the dispatch async, you can see thread is blocked until this method executes. So this is the basic difference. And here you can also find out the difference between the dispatch, that is a manual thread management, non-throwing suspension, and no automatic cancellation for this. But when it comes to task, we can have a built-in cancellation support, and also throwing suspension and non-blocking operations. And next, we have a structured concurrency. So that helps in the task management, organized and efficient. So here, thread safety is we can able to properly handle those things, and also lifespan management. If any issues with the child task, that can be propagated to the parent task. And this is the structure flow of these structured one. So we can based on the async and await, we can able to do. And I would like to give an example for structured concurrency. Here is async let. So we might have used for downloading images. So async let will be really helpful, and also it is very faster. And we can able to use async let for fetching images from URL. So you can see, and for getting appending those or reloading something, we need to have the await. So this is the way of we can able to implement the async await. This is a structured concurrency example, and you can see the try await. So that creates a suspension point, and you can see the output for this, and it starts with, it can be randomly based on the size or something threads, and you can see the response from here. And the pros and cons, so it was introduced similar to sync await, and also proposed on 0304, and so we can able to integrate with the async await, async let also, and then we can have a multiple task also using this, and it helps in the safety and predictable one. And there are some cons, that is similar limited backward compatibility for this, and complexity in the large code size. So actors are really helpful, and it helps to prevent the data races. So, and actor isolates the like internal state and allowing only one task to modify it at a given time. So that prevents the data race and ensures the concurrency safety, and is easier to write safe and predictable concurrent code. So here you can see the task, and when compared to serial queue or some queue, it is not a first in first order. So it always go with the highest priority and go with but it will work only for only one task at a time. So this is a good example for class and actors. So you can see in the class, in this example, the counter dot increment, if you increment from 0 to the result can be 1 or 2, and this creates a data race. And even though actor is a reference type, but it helps in the preventing the data race. So here we have used the task data set, but here now wait, that creates a suspension point. So that helps in the preventing the data race, and also go with the shared mutable state. Here, so it was introduced in 5.5, and actor isolation is the new changes in Swift 6. We will be seeing in the next upcoming slides. And data safety and simplicity can be, and we can able to easily integrate with the async await and task that helps in the isolation. There is a one few like actor re-entrancy that we will be seeing in the next slide. So for example, we have an actor actor, and we are the two tasks are communicating with the actor at a time. And here we have added the await function. So that creates a suspension point. So before accessing the task 1 and task 2 completed, then the state will be modified. So this is the way we have an actor reentrancy issue. So actor is suspended during a task, and another task entered the actor while the first task is suspended. So this is caused by the actor's reentrant behavior. So before seeing the isolation, I would like to tell about the sendable. So sendable is equal thread safety. It's the best example for the thread safety. It was introduced in the Swift 5.7, and it's just a protocol. And most of our base types of Swift foundation are sendable. And you can see the date that conforms to the comparable, hashable, equitable. But now we have a sendable. So, and also array.init. So you could see the sendable protocol has been confirmed. So for more information, you can also see this Swift evolution. And here they have mentioned about the sendable and the sendable closures. And that helps in different ways, like value semantic or immutable classes, and also internally synchronized reference type such as actors. So first we will be seeing this value types. So whenever we are conforming to structure to a sendable, so it acts well with the value types, because even though we mutates, it will be in the particular isolation. So that is one of the benefits. When it comes to the in terms of closures or functions, so we need to add at the rates sendable closure. So this creates a better thread safety for the closures as well. And we have internally managed access to the set, that is actors. So that really helps with the sendable. And actors, we don't need to explicitly conform to the sendable. It is implicitly it is conforming to the sendable protocol. And now finally we have a class, but classes are reference types. But for conforming to the sendable protocol, we must have a immutable storage, and also the class should mark final. So then only we can able to conform to the sendable protocol. Yeah. So what is isolation? So before going with the actor isolation, I think isolation definition is must required. So this is used to make data races impossible, but it deals with accessing the mutable state in unsafe ways, not all the data races. And we can isolation can be changed whenever you are using the await keyword. And isolation applies to variables, functions, closures, and protocols as well. There are three types of isolation flavors. So here, none. That by default, everything is non-isolated. So we need to have explicit action for this, like actors or await. And static, you can see actors, global actors, such as main actor, and isolated parameters that we'll be seeing in the next slide. That helps in the compile time enforcement of the isolation. And dynamic, like assume isolated, precondition isolated attribute that helps in to allow at the runtime. So prefer to go with the static isolation for compile time safety. And consideration for dynamic, it offers flexibility, but it might introduce the data races. So this is a simple diagram for isolation flavors. And so we will start with the none. So by default, everything is non-isolated. So there is no specific isolation enforced. So you can take an example like synchronous code, just a normal function that is a non-isolated. So we can take this example for it has a non-isolated added. So we will cover the non-isolated in upcoming slide. The static isolation. So first we will be having the actor isolation. So only one task can execute on an actor at a time. So that prevents the data races that we have already seen. And no other task can modify the state concurrently. And also here actor that it is not strictly first in, first out, like how we have a dispatch queues. And sendable checks is always there enter and while entering and exiting an actor. Actors are implicitly sendable. And you can see this example. So they have a this is isolate. We need to check whether it's isolated or not isolated. So we have a two variables and functions and also two tasks placed on. So this is not as isolated one because we have a task detached. So that detached means that will be independent task that cannot be tied with the context. So it runs in the independent level. So we can't use this as a isolated. So we can remove this task detached, and now we can see this. This is a actor isolation, and we have a main actor isolation. So that is that works on a main thread. So it is isolated for UA related code to prevent concurrency issues. It might create some UA issues if you run more on this, but it only run a single job at a time. And the tasks that schedule between the main actor and other actors. So you can see the sendable in the sendable, you can see the classes marked with main actor that are implicitly sendable. So we don't need to explicitly call the sendable protocol. So this is an example for updating a view. And then we have isolated and non-isolated. Generally, actors are automatically isolated. We don't need to mark anything. If you are marking a specific methods or sorry, properties or parameters, we can use the isolated. And non-isolated, whenever we are bypassing some actor isolation, we can able to use the non-isolated. Generally, in protocol requirement, we can able to use the non-isolated because it cannot be isolated for different. We might use the classes or something, and we can mark properties or methods as a non-isolated. So this is an example. We have passed this isolated parameters. And here you will be getting the error because we are confirming to some custom string convertible protocol. So when we update the description, it will not be updated. So for this, we need to add the non-isolated to update the description. And here you can see the review this Swift evolution proposal. And isolation boundary is nothing but, so we have a private variable and followed with the two functions. So those are isolated, and those functions are accessible within the actor's boundary. Safe modification, even accessing concurrently by different tasks. So, and dynamic isolation, that is assume isolated. This is a synchronous one, and we can able to assert isolation for the non-task code. And here there is a precondition isolated. So it is also similar to assume isolated, but is a assert isolation at runtime, and it's adds a runtime check to ensure the correctness. And here the task isolation, so it can be in a dynamic only. So tasks are isolated independently executing async operations. Sendable checks are there, and whenever we are need to share some values, we can use the sendable constraints. So you can see the struct where success yeah. So we can able to see the in the result type success that confirms with the sendable. There are some challenges of isolation, and there can be a context switching, or actor can introduce some delay, and because it allows us one task at a time, and the sequential execution can impact the performance as well, and unchecked sendable can lead to bugs, and it's difficulty in integrating with the legacy APIs or libraries. So, so when we found finally understood the async await. Now there are some new features they have added in Swift 6. Let's explore Swift 6. So coming to Swift 6, that compiler supports from Swift 4, and also deals with the data race safety, and it expects everything should be sendable. We have seen earlier, and actors should not. It's not strictly first in first out, not similar to dispatch queues. And we have a non-isolated unsafe. It's kind of unsafe only, and we have a pre-concurrency and uncheck that needs to be handled with careful consideration. So you can see the 5.5. They have introduced async await task test, and 5.6 we have the pre-concurrency, and in the around 5.7 we have a sendable, and recently we have got the full data isolation, isolated globals, that you might have seen the concurrency check in your build settings, and now in Swift 6 you can see this data race safety. So what are data race? So whenever the two threads concurrently access at the time, so one might have a write access, or both of them have a write access. So it can be caused by the shared mutable state. So yeah, here you can able to understand the result could be one or two due to the data race. Yeah, and also it is done in independent one. So this is an example for the data race. And you can see the example for this. Thread A and thread B that communicates with the counter, and it has a shared mutable state. So that causes this data race. And if you see compiler support, as I told you, it supports from the Swift 4, and it helps in the backward compatibility. And we can have a migration technique to advance our features and improvements, and we can easily integrate with the async await. And with the help of continuation, we can also migrate our old closure codes to async await, and larger old code bases can be migrated. So that brings us stability. So here the sendable is sign of having too much isolation boundaries, and everywhere we have got the sendable. And because of this, we need to introduce more actors into our code. And if you see in the sendable, you can and adding to the closures and main actors. So for understanding more about this sendable for methods and key path, you can also refer, and we can see this upcoming feature flag in the upcoming slides. So here actors are not strictly first in first out. This is the key difference between the serial dispatch queue. So actor priority is the highest priority to work first, and also it eliminates the priority inversion. Priority inversion is nothing but lower priority task that works before the higher priority task. So that is a so we can eliminate. So order of execution for a task, because of for one task that is a specified order, but whenever order between the task, multiple tasks we can't guarantee, and async streams that helps in the delivery elements in the order. So we have a pre-concurrency, so that can be added to functions, types, protocols, and also import libraries. So we can we can able to migrate our old legacy code base to new one. So using the pre-concurrency that could solve the compiler errors. And non-isolated unsafe, so can be used for annotating the global variables, and this helps in the static checking and data isolation for this. In some, if we found any failures that can be found in the thread sanitizer, you can see this example. So we have unchecked that it's just a bypassing the compiler checks. So whenever the type conversion or a data access for performance optimization, we might use the unchecked. So that could help in the performing the application. And these are the differences between these three. So whenever we are having a older code base, I would suggest go with the pre-concurrency that can solve the warnings we will be receiving when we migrate to Swift 6. And bypassing a compiler, that would be unchecked. And bypassing the actor isolation, we can go with the non-isolated unsafe. So all these can lead to a data races. And there are some use cases you can see. And also it is unsafe outs, but it defeats the purpose when we are not carefully considering the things. So we might get some issues in further. Yeah, these are the proposals that are related to concurrency in Swift 6. So I will be illustrating each one by one. So there are, I think, 11 things. So it will be starting the strict concurrency and default value expressions and region-based isolation and actor isolation inheritance. And also sending parameters and isolated any. So you can see in the incremental migration to concurrency checking, like we can able to adapt the Swift concurrency in the legacy code base. So we can simply use the upcoming feature flag, and we must enable this in Swift 6 language mode. And this will be help in transition to concurrency safety. So we can take an examples. And next, region-based isolation. So in you might have seen the 5.10, we have been getting some errors, compiler errors when we update this concurrency check to complete or targeted. So there were some issues in the passing all the non-sendable values across the isolation boundaries. So for this, they have done introduced the new mechanism to enforce this memory isolation. So in this example, it was not, it was giving a warning when we have tried to access the non-sendable outside of this main actor isolated. So here in this example, this is a Swift 6 and it's the updated one, and we can able to pass the values. But here there is some, there could be some data race that I saw from one of the article, and we could be able to see here also we are updating. So that could result in data race. Anyways, in this the beginning, so we can make our code safer by resolving these conflicts. So it is very important when it comes to working with the concurrency. And next, task executive preference. You could see some of the tasks we might that was not available, and sometimes it might slow down when the Swift provides some executor. So this fix would allow the preferred executor for the task. So you can see this, you can able to add the preferred executor, and here the serial executor that guarantees mutual exclusion, and task executor that gives a source of threads. Here, this will make a thread safe, and it will go with the serial. So this helps in the task more efficiently, and followed with the inferring sendable for methods and key parts. So there were some methods we need to mark it as a sendable, and some key parts in manually. So to avoid this, so manually we might miss, or that could raise some issues. And now this fix that automatically infers the sendable for these methods and key parts. So we can directly use this value, and this makes the code cleaner and safer. And inheritance of the actorization, we have seen the actorization before. So there is some complexity in actor inheritance. So in this, we can see we can't able to access properly, and there is some issues with like we need to add some extra code for this. And here in this updated one, we can able to use the isolation. So general actor or isolation, we can directly use this, and that helps in the actor inheritance. So using isolation parameters that prevents the suspension on the call side and compared to await. So it is very useful, and when we are using the isolation parameters. And so we have a dynamic isolation that enforcement from non-strict concurrency context. So you can see, take an example of delegate that can be used by any other classes or some that in that way, like we were doing like adding a non-isolated in before the function to that work will be the classes that conform to the protocols. So for this, they have introduced this pre-concurrency. So we can make use of this whenever we are going with the protocols. So when we have a mixed code bases, like we were using a older concurrency, at that time we can able to use this. So this create this bridges the gap between the legacy and modern. And custom isolation checking for a serial executor. So for checking whether it is the isolation, we can able to check easily for the executors. So this is the you could see in your Xcode, and you can see this check isolated has been introduced. And this is the implementation that I found in the Swift Revolution. So they have used the existing dispatch API for this to check the isolation. So this gives more control on the task execution, and adds a new sending parameter. So that ensures this data transfer across the concurrency boundaries. So introduction of this sending keyword that helps in the more stricter concurrency safety. So if you go to this task init, and you could see this sending parameter. So it is they have started adding this sending parameters to make it a sendable thing. So that helps in the more safety, and also sendable is more important, but sending is less important when compared to this. And isolated any function types, there is an inconsistent isolation control whether. So you can see sendable, even though we have a sendable escaping one. So, but we have lost all the static isolation information in this way. So for this, we must have isolated. So that helps in the closures as well. So we have now we have a closures have the properties as well. So this improves the safety for whenever we are passing some isolated parameters or isolated thing, root closures or functions. So usability of global actor. So you could see this issues. We have a structure that has a main actor isolation, but we were unable to access this why. Yeah, so in 5.10 we were unable to access this, and in 56 we can able to access this. We have resolved this when we when we added the non-isolated function. And similarly here, we need to add a sendable before the main actor. So it was a warning, and we need to add it manually. So now the main actor implicitly confirming to the sendable. And this is isolated default value expression. So the example was confusing for me. So I think I would suggest to go with the Swift evolution page. You can refer this example. I think you can scan this QR code, and this helps in the default value, ensures the default values are executed within the correct isolation context. And, so now we have a Swift 6 migration. So even though we have a good architecture and we have all things, but we have a main queue running and our background queue running over this health kit controller. And also we have a valid types and also reference types also, and delegates, all those things. But we are not sure where this how can identify the data rises or anything or raise condition. So if you see in the architecture with Swift concurrency, you can see they have you can see the main actor that works well with the views and also models. And we have a separate actors for these data store and health kit controller, and these are the value types. So we can able to switch to Swift concurrency with this by using the actors and the main actors that serves better. So how to migrate to Swift 6? So we need to determine the isolated part and enabling the complete concurrency check in the build settings. And we need to enable the Swift 6 mode, and we can audit some unsafe outputs like pre-concurrency or unchecked or not and non-isolated unsafe. Those things we can implement. So before migration, when to migrate? So whenever we are unable to understand the concurrent code issues, sometimes we might get the crashes, or we are unsure about how the data race have happened, or some thread explosion. Those things we are unable to find. And also we have integrated more Swift concurrency. And if you have any public Swift package manager, it's better to migrate the package to Swift 6 so that your users can utilize the latest version. That helps in preventing the data races. So these are the feature flag. In Swift 5.10, we might have got this enable experiment feature. So these global concurrency we have seen in the strict concurrency for global variables and infer sendable. So for key path literals and also region-based isolation, we can also check, and strict concurrency we will be seeing in the upcoming slide. So we might have seen this in the build settings for compiler upcoming features. So these are the upcoming features flags we can able to add. And other than the concurrency, we have some flags also, like so some of the flags we can able to like internally ports those things and trailing closures and everything. So this is the minimal level of concurrency check. So only checks explicit to sendable one. And you can see this example, like we have a actor and then we have a balance. We have a variable balance and deposit. And whenever we are performing the transaction outside the isolation boundary, we must have the await. So that helps in the resolve this problem. And targeted, so we can able to switch to targeted. So here you can see this class profile and also actor bank account. So whenever we are updating the user profile and also making a transaction outside the isolation boundary, so I have replaced this user profile to structure that conforms to the sendable. So this will work well. And even if you can have a final class that helps in the to resolve this issue. And next is complete strict concurrency checks. So after setting this, we need to enable the Swift 6 mode. Here you can see the Swift language mode, and you can able to modify this. This is the final step of the migration to Swift 6. And these were the errors I have seen in my one of the projects. So you can see some of the things that concurrency is safe because non-sendable, and main actor isolated method. So we might have used the old libraries. I have used for this core Bluetooth that might have upgraded us. Whenever we are doing that, we need to isolate to main actor or actors. So here you can see the main actor isolated, so cannot be referenced from a non-isolated context. So for this, I have added, modified this function that is a main actor isolated. In one class, we might have similar methods. At that time, you can add the main actor to the class itself. So that would be a main actor isolated instead of marking each methods. And we have a other example is static property becomes non-sendable. So here there are two options we can see. So one is we can go with the main actor or non-isolated unsafe. So we can go with the main actor. And services, you can see the unchecked. So implicitly your session delegate that conforms to the sendable protocol. So we can use the unchecked. And pre-concurrency for updating the pre-concurrency for the delegates. And also here we have two options. That is, we can use the let if we are not mutating the values. And other common things, errors are these. And these are the common errors you can see in the Swift document. And this is my SPM that I have enabled this upcoming, and I have modified to 5.8. And I have used the sendable closure. And these are the zero data race safety errors. These are the graphs you could see. So yeah, I think it's end of this speech. So whenever you can use this async await and continuation whenever you are going with the callbacks, and assimilate for concurrent operations, and sendable. Also actors and isolation data eliminates the data races, and pre-concurrency for the legacy code, and enable this concurrency check and prepare for the Swift 6. Yeah. You can scan the QR code to download the latest repo for the playgrounds.
Hey, Sabapathy, thank you so much for that engaging talk. It was really nice. I think folks who have been coming from unstructured concurrency and dispatch queue, they would be feeling it really intriguing to sort of learn from your experiences and all these talks. I would like to go back to the questions that are there first in the chat thread, and I'll then open the desk for folks to ask you questions. The first question that we have is like from Purna, who is asking sort of to you to repeat the difference between a task and a dispatch group.
Okay, yeah, sure. Yeah, so you can see the task. So yeah, so before task, you can see this dispatch global async. So we are running on the global dispatch. So here the thread will be blocked until this returns. So, but in task, so you can see the await that creates a suspension point, and also that it is unblocked to allow thread to proceed with any other works, and after that it will resume. So it gained back the control once the thread resumed. So And one more is you can see this example. So we are manually doing for Grand Central Zip Dispatch. And here is an inbuilt cancellation for task. Abhishek, yeah.
Yeah, Purna. So, Purna, do you have any follow-up questions on that?
Yeah, what is a suspend state? I'm just trying to understand. Suspension state, suspension. So,
Yeah. So whenever we are using a suspension point means we can see this. We are using the async method and we are calling some URL, and that is using with await. That creates a suspension point. At that time, it will allow other threads to go with other methods or other works instead of going with the same URL. Once we get the response, it automatically resumes. So that is a suspension point.
okay. Yeah, thank you.
Yeah, I think Purna, that answers your question.
Yes, Abhishek. Yeah, thank you.
Thanks, Purna, for dropping that question. Sabapathy, I'll move to the next question. I don't think so. This is a question from Ratnesh, but Ratnesh is probably dropping a confirmation around sendability, where he says sendability means the instance of these types can be passed around multiple concurrency context without concerns of databases or concurrency issues. So I think he's probably trying to share his viewpoints on sendability. Yeah, so if you could highlight around that a bit, where he says sendability means that the instance can be passed around multiple contexts across the code without the client being really concerned about the implications on threads and databases and all sort of things.
Yeah, sure. So yeah, generally sendable that it's in the thread safety. So it's a separate protocol. Yeah, that the so whenever whenever we are sharing between the two tasks, at the time we can go with the sendable constraint. So that can be a thread safe one. So that's why we are using the value types and actors that helps in the sendable one.
Thank you. So moving on to the next question is Purna again, where he asks that what is the difference between deadlock and data race?
Data race whenever we are having two threads that communicates with the single variable or single thing, so that creates a data race. Deadlock, we might get the suspended one, or we are unable to move further. So yeah, anyways, it plays with the multiple threads.
Okay, yeah, thank you.
I think there is another question from Arpita, but I think Arpita, I think we can take this question in the Ask Me Anything session post this, because it's a very generic question and we'd love to help answer that. But yeah, let's discuss this post Sabapathi's talk. Yeah. Is there any other questions that folks can directly ask to Sabapathy? Then please feel free to unmute yourselves and ask. Yeah, I think Purna has a question. Maybe I think if there are no other questions, I would like to take this as a closing question, where he asks how to prepare concurrency in interviews, what are important topics that needs to be learned, and are there a lot of topics to learn? So yeah, Sabapati, I think
Concurrency and multi-threading both. Yeah.
yeah. Sabapati, please.
Yeah, sure. So if you have any experience in pre-concurrency such as GCD operation queue, so if not, you can just learn about the basics and to go with, and we can forget about the combined framework right now if it is complex. I would suggest to go with async await and structured concurrency and the tasks that help you more learn more in depth, and also actors. So in the Swift 6 you can see the actors plays a major role, and also you need to understand the advantages also and disadvantages. Yeah, so I think these are the topics you can learn where I have elaborated here. You can check these topics. And for resources, you can check WWDC or Apple documentation, and I will share the link where I have referred. So I will share. So that helps you more understanding in the new Swift concurrency.
Yeah. Thank you very much. Thank you.
Thank
you. Yeah. Thanks, Puna, for that question. And I think the general things is that with dispatch queues still in progress, right? And I think we're not ditching dispatch queues very sooner. So I think it's very important to prepare both of dispatch queues, the GCDs and the Swift concurrency parallelly, right? Because if you're going and picking or probably working in some existing projects, you will definitely hit dispatch queues and GCDs right on your way. And probably the new ones would be using Swift concurrency. But it's eventually better to learn both of these things. Swift concurrency makes it more simple, and you don't really care about a lot of this threading issues, right? Because the threading and every other things related to threads are taken care by the framework. But if you go back and do the same with dispatch queues, it's a bit different over there. You need to be a bit, what do you say, bit careful around constructs, like how you're using concurrencies and asyncs and what do you say, sync blocks, which is not generally the case with Swift concurrency, right? So it's better to learn both of these things, right, to come up with solutions. And with like, let's say if you're talking about specific with interviews, then I think you should be prepared to face both of these topics, right? So yeah. Yep. Yeah, so what are the next thing? Can you get screen recording? Yeah, I think the screen recording would be shared. Yeah, Nine has replied this, so yeah. So is there any other questions for Savapati? If not, I'll just pause there for a moment to see like if there is any other questions.
So if I want to master the concurrency, what are all the things I need to learn about? It's like it's like a basic flow chart. These are the basics, and then I need to go for this for advanced level so that I can able to understand the flow you explained now.
Yeah, I think this flow you can start with, and later you can learn some more details in depth. So now we are going in this Swift 6, and so that will have a more compile time errors, and that will help us to understand the data race. So that is a recent one, and you can learn from this if you are starting with you can learn from GCD and other stuffs, and especially Swift concurrency. In this flow you can learn. That will help you.
Cool. Thanks, folks. I think we'll probably swiftly move to the next topic. If you do have any other questions, I think you can definitely go ahead and reach out to Savapati over LinkedIn or other modes of communication. I think we have his contacts listed as well. And anything related to this PPT and the recordings, I think that would be shared across. I think Nan has already mentioned how to do that. So please follow the chat thread. So I'll move to the next section, right? Because I don't see any other active questions. But before moving to the next section, thanks, Avapati, again for that wonderful presentation. And I think that's a much needed topic to discuss upon. So thank you so much for taking your time and giving that effort to sort of, aware us with all the nitty-gritty details about Swift concurrency. Moving on, I think we have a Ask Me Anything session. So I think this section is something that we are starting anew, I think, from the last meetup, and it has proven to be worthful. But I think this is something that we wanted to have it open as an open forum where we would encourage you to take this opportunity to ask questions from different other senior and experienced folks across the industry on these topics. So let me go to the panel members that we have amongst us. We have Shubham Singh, who is currently working as a senior iOS engineer at Delhi Rounds. You might would have seen Singh's topic across in LinkedIn, and he has a widely followed Insta channel where he posts a lot of this animation stuffs across related to SwiftUI. And I'm from an era where a lot of these social media things were not there. And but the way that Shubham puts it forward, it looks very easy for animations to get carried out. And he has been posting the SwiftUI stuffs from quite some time now. So yeah, please drop a hi for Shubham. So you can follow Shubham in LinkedIn and you can see his exciting works over there. But yeah, with that, I'll move to a more veteran in the industry. His name is uh, Pran over here. So Pran is a lead software engineer at EPAM Systems. He is also a very active member of the Swift Bengaluru community, and he has led a couple of meetups across, not in Bangalore but outside. We are very grateful for for the Pran and Shubham to have joined us for this panel discussion. Pran is someone who is very experienced into both UiKit and SwiftUI, right? He's a very seasoned iOS engineer, and I hope that he would be able to answer a lot of your queries that you have had. I have seen a lot of questions that had come up in the previous meetup. So feel free to drop any questions to these folks. I think one who has a lot of experience into both UiKit and SwiftUI, and Shubham, who is very well versed with this new generation of engineers, right, who are very excited into the SwiftUI development, right? So yeah, let's move on and probably start dropping these questions. But I think before that, I think I would start the discussion with a very generic question, and I would like to have inputs from both Shubham and Pran. Like, what are their thoughts on SwiftUI versus UiKit? So I would sort of request Shubham to first share his thoughts, and then I'll be moving to Pran.
Okay, thanks Abhishek for having me here and for the great introduction. So yeah, it's a hard question to answer actually. Like if you still see the companies who are actually like working with both UiKit and SwiftUI, you'll see that most of them are still relying on UiKit because they have to still support iOS 12 and so on and so forth. Then there are the second set of companies who are going in a more of a mixed approach in which they are using both UiKit and then trying to use SwiftUI on top of it, and then you have the new companies who are mostly relying on SwiftUI. So I think yeah, Apple is definitely pushing SwiftUI more and more because they have so many new frameworks which are only available for SwiftUI. So it's definitely the future. But I still like, even for bigger projects and all, I still like the reliability of UIKit, and then I mostly tend to use SwiftUI on top of it. So I think yeah, both has its own place, and it's just yeah, up to you. Like even if you like start to learn UIKit first, it will definitely complement your SwiftUI learning because the way of achieving things might be different because SwiftUI is a declarative programming, but the concepts, how the layout is done, and how you can basically integrate both of the frameworks together works really well. So I think yeah, both are great at their own places, and it mostly depends on the minimum iOS deployment target and yeah, what you want to achieve with it and the scale of the projects.
Yeah, thanks, Shubham. I think we'll take that as a very light note, just to kickstart the conversation. This is a pretty icebreaker session, so do expect more and more questions flowing from our audience over here. So with that, moving on to Pran. Pran, what are your thoughts, right? So you have seen many of these generations pass in iOS, right?
Yeah.
Languages switching and stuff's happening across, right? So what are you?
So, to give a nostalgic feel to this conversation, I would start when I started programming. Auto layout was launched for at WWDC. So that was the latest and the coolest thing at that time. And now we have moved on, like, tectonic shifts, right? So yeah, UiKit and SwiftUI is a hot topic. But most of the time, what we see when we work with large scale projects, those are existing applications, as Shubham said. And yep, still picking up on SwiftUI. It takes some time for folks to start working. So if you ask me, if someone is saying he would take X amount of time to do something in UiKit and he would take Y for SwiftUI, if that's a difference from a project manager's perspective, they tend to UiKit. So that's the right now main motivation, and of course backward compatibility support. That's still a big thing for many applications who are into travel and hospitality, like airlines, or who are into banking. They cannot lose their customers like that. So that's a barrier still. Maybe I see this breaking in like next couple of years at least.
Yeah, thanks, Brad. I think that was something that was definitely the answer that I was looking from you. And if we correlate your answer with Shubham's, we can see, right, how this beauty is coming in. I myself, I had started just fairly with Objective-C, just hit with auto layout and Swift, and now we are getting the SwiftUI stuff, right?
Yeah.
You can see this whole beauty of things that is coming in place. And thanks for sharing your viewpoints across, right, both Shubham and Fran. So I'll not probably sort of jump into some other questions. Rather, I would open this forum to people, right, who have any genuine questions, right, and who wanted to discuss this with you directly. So, folks, please raise your hand if you have some questions, right? And please take this as an opportunity to ask these folks, right? And it would be hard for you to connect with them in person, right? If you want to separately, but take this opportunity to ask this folks some questions you have. Okay, yeah, I think we have one question from Vinayak. So the other folks are still probably thinking like how much tough of a question that they can ask you guys, right? So they're probably brainstorming to ask that question. So let us give that time and probably move on to the question that has been posted by Arpita. So as I'm a fresher, okay, sorry, there are a bunch of questions. Okay, yeah, the first question was from Vinayak. Sorry, I just reversed my stack. So what are the currently known issues with SwiftUI from first performance, second feasibility point of view, due to which I should go with UiKit? Okay, great. So this time I'll start with Pran and then I'll move to Shubham, right? So that Pran doesn't feel that, hey, why is Shubham going front first, right?
So
I don't have any issue with Shubham.
so I would make a honest statement first that I am still new with SwiftUI. I am doing it, but not as regularly and frequently as I guess Shubham, because I see lots of cool stuff from him already. And but in terms of feasibility point of view, if you ask me, you should try to compare your use case, check your use case. Where do you want to go with your project. So if you are expecting that if you use SwiftUI and it would be easily usable in watch, iOS, macOS, tvOS, anywhere as Apple claims, it is, but you will have a lots of surprises in terms of themings, um, subtle behaviors, colors, layouts, so that surprises would be there. Don't think that it will be out of the box for all platforms 100% same. So there will be some places you still might have to customize that particular use case for that particular platform. So decide your project in a way that if you have some component which is used only in one given platform, then what is your use case for this? Do you need a lot of customization and things like that? Based on that, you can take a call which to use SwiftUI or UiKit. If you have to use across multiple platforms, SwiftUI is the way to go. But do not think it as a silver bullet for anything.
Yeah, I think I would expect such an answer from Pran, because I think it's easy to say like what to do, but it's very difficult to say what not to do. Right? And that is where we have got this varied panel members like Shubham and Pran, right, who would enlighten us from both the directions. So Shubham, next to you, right? Where would you say, like, why would you not choose SwiftUI, having sort of experience with SwiftUI from this past couple of years, right? Where would you not choose SwiftUI in terms of
Yeah,
all
now,
these points?
got
Yeah.
it. Coming to the that performance question, like first of all, let's just answer that. I haven't seen any major performance problems while using SwiftUI. I think it's become even better with the introduction of the observation framework, that you can simply use observable macro and then use simple variable without having the need to use published properties and all. It's become much more faster and efficient, I would say. But even with the previous environment object version, is still like usable. I haven't had major problems until I've used like core ML stuff. So I think, yeah, performance wise, SwiftUI is definitely like much faster. While coming to when I'll not choose to use SwiftUI is, again, like first of all, I'll just see if what's the minimum iOS deployment target that we are looking for. Second would be the scale. So if the scale is like a small to medium project in which there is not like I don't have to take care of multiple navigations, then I still prefer to choose SwiftUI. But as Pran said, if I have to customize the navigation controller in different view controllers or different screens differently, or maybe changing the appearance of some tab bar and things like that, then I'll prefer to go with a UiKit based approach and then use SwiftUI on top of it. So I'll maybe just use like UI hosting controllers and create SwiftUI, because yeah, it definitely saves up a lot of time while creating the UI and then use on top of it. Again, it's provided that the iOS target is at least 13 or 14. But yeah, if that's a large project which requires complex navigation, which has like tab controller setup, in which maybe if I have to provide for backswipe navigation gestures and things like that, I'll choose to go with a UI kit based approach because it's more reliable.
What a valid point to conclude your answer, Shubham. I think when you talked about reliability, I think UiKit has proven itself from back from Objective-C eras till now. And the navigation stack is something which is very, very impressive, right? If you look at the various architectures that we have in place, like coordinators and other stuff, which purely relies on the fact that we have a reference-based navigation stack in place, right? And that is where you would generally choose the navigation stack mechanism. I have worked with organizations where people still have a coordinator-based navigation approach, and they use navigation and the skeleton of UIKit, and then they use SwiftUI's views to develop things faster, right? And I think that is where you need to take a balanced stand, right? What to choose when, right? And what not to choose, right? Again, circling back, you know that what needs to be done, but you do not know what needs to be done, right? So you have to strike a balance. And yeah, thanks Shubham and Pran for sharing your thoughts on that question. With that, moving on to the next question, I think it's from Ajit Madan. So I'm struggling to decide when to use Viper versus MVVM for my project. What are the key factors I should consider when choosing between these two architectures? Yeah, great, great. I think very great question. I think let's hear this in context of both SwiftUI and UiKit, right? Because I think MVVM and Viper can both be used in SwiftUI and UiKit, but there's a bit of trick to it, right? So let's hear this out from Shubham and Fran. Yeah, please. Yes, sir.
Yeah. So deciding the architecture is a very a personal question, because you'll read so many articles and people will tell you this architecture is the best, this architecture is the best. But I feel that in the end, the best architecture is something that works for you. So I personally haven't. I'm not a fan of Viper. I have not even used Viper in multiple projects. I have used MVVM and it works well for me. Whenever I try to create a new project, whatever requirements I have, I immediately will figure out a way to break it down into the MVVM architecture of data flow, how to use repositories, how to use use cases and all. So I believe you have to experiment the architecture with a bit and then figure out the requirements of the project. I think that's it. And this works both with UiKit and like SwiftUI. SwiftUI anyway follows a by default MVVM architecture, in which you already have a UI view in place. You just have to create a view model with which you can pass the data to the view. So FUI again in UiKit, by default it's MVC, and I think there is a viable way to make MVC work as well if your project requirement is not that big as such. But definitely, if you see in terms of scalability, and if you see in terms of reusability, then an MVVM architecture with a repository and having a navigation router with a coordinator makes sense. So I think I'll say MVVM is good, but I'll still request you guys to try creating small projects, try figuring out okay, I'm facing this problem, how should I do it better? Then you go ahead and research a little bit on the architecture and then try to incorporate it. So I think that's the best way to learn. And yeah, so for me MVVM works the best, and I'll say MVVM is good, but again it's like very opinionated, so it's what my experience has been. So I'll still ask you guys to try out multiple architecture, but whatever based on your project needs. I hope that answers the question.
Yeah. I think that fairly answers the question. I'll move to Fran. Fran, what are your thoughts on this?
My thoughts on this are, I should say, out of the box and not a general one. What I have felt across my large experience in multiple large scale projects where you have 30, 40 people team, and someone is doing Viper, someone has done MVVM in some module, someone has done MVVM in like 3, 4 ways. So I have spent 5 to 6 years only on MVVM, right? But what I understood and what I would gist is focus less on architecture, but not in a way that Viper and MVVM like that, but focus more on solid principles, which are principles by the book, right? And try to make your code more closer and adhere to it. This can be practiced. It's really not easy, I would say, in the first go, because generally an approach is to like try to accomplish a task and just do it, but you need to do 5 to 6 rounds or even 7 to 8 rounds. So if you ask me an honest answer, I have worked on multiple permutations and combinations of MVVM to even absorb the content for 3 to 4 months straight. No new topic on Swift, but only on MVVM. No Viper, no clean, nothing. Only MVVM, right? So with that, what I imbibed was if you go with solid, if you have a modularization right, if you have your unit tests and structures right, which are core principles to move along in large scale projects, I guess you are very in a good shape. Most of the projects have spent more than 30 to 40% of the time only on refactoring architectures, where people have refactored one thing 4 to 5 times, which I think is definitely not was not worth it. But if that time could have been shared between performance audit, security audit, how your which areas of your app are performing. So there are many avenues which you could optimize, storage, app size. So these things should gain more priority than actually refactoring, right? So go for an architecture which sticks to more solid rather than MVVM or Viper or something like that. I would, that's my core. But yeah, definitely, as Shubham said, some architectures favor some kind of projects. So yeah, of course, in some cases, one part of a way of writing a code will serve you a better purpose.
Yeah, I think that absolutely makes sense, Pran. So the reason is like what do you say? I would admit, like what is I'd be admitting one particular thing that I heard from Shubham, and I think what Pran also mentioned kind of similarly correlates to it. We cannot be fixated on one particular architecture, right? Eventually, what suits to your business use case, right? That is what brings along. I'm not sure how many of you know that Uber, Grab, these folks they follow Riblet as an architecture, right? And they follow it from the smaller views to the larger views as well, to the larger use cases. And why do they do that? Like if you ask me that, hey, like I can use Viper for the larger use case and MVVM for the smaller use case, then why didn't Uber allow this, right? Because another thing is that when you work with a larger team, right, what Pran mentioned, if there is a huge team, you also need a consistency as a factor to it, right? Everything cannot be looked at the point that hey, I just need to ship and build it away and just be done with it. What happens when you scale things? You can't just refactor your things at very small thing, right? Like refactoring is not a small thing. It comes at a cost, right? The let's say I keep engaging Pran to shape the architecture. I start Shubham to refactor all of these things, right? So we are spending a lot of these efforts where these folks are engaged into refactoring, where a little bit of effort could have been put in earlier stages to think through the architecture, right? So that is where we have to take this call in our maturity that what fits our business use case, right? And to a foreseeable future. What happens post 1 or 2 years, we don't have a control over it. But definitely for foreseeable future is something that we need to take care of it. The next question I have is from Arpita. Arpita, and I think I have seen a lot of questions in the chat thread, which is basically from a lot of junior engineers and freshers, Pran and Shubham, who are actually seeking a lot of guidance, I would say, around how would they prepare for interviews, how would they prepare in this current market conditions, right? How would they basically approach this all things, right? But I'll just keep that as a closing point to our discussion, a closing section, right? So where you guys can share your thoughts on guiding them on this path. But before that, let's move to the next question, which is from Nazim. Nazim wants to understand that what is the aspect of the memory management in SwiftUI, right? How is the automatic reference counting mechanism gonna handle structs as SwiftUI uses mostly structs, and structs are not reference type. So I think what he's primarily asking is that we definitely understand that ARC kind of works in what context, right? Because object and reference counting. So when reference type is out of the picture, so technically and logically thinking ARC is right out of picture, right? So how is memory management being handled in SwiftUI? I think if I just have to put it in plain words, yeah, please.
It's okay. I'll start now. So I think memory management, yeah, again, as Nazim mentioned, because it's just all structs and mostly value types, you don't have to actually care a lot about the memory management in the SwiftUI views. But when you actually come to your services, right, when you are using observable objects and using other services which are actually providing the data to your UI views, those will mostly be your classes, because yeah, observable object can only be like used if it's a class object. So that is where your memory management comes into place. So that is where you have to like take care of using tasks if you're using async await, and if you're like trying to do heavy IO operations, then you'll have to take care of dispatch queue and all. I think because it's a class, you can still like implement the deinitializer function and see if your ARC and memory references are getting cleared properly. But yeah, I think that's it. That's how much you need to take care of when you're working with SwiftUI.
Yeah. I think that makes sense. Brand, what are your thoughts on this?
So one of our uh, team, one of our joinees from this meetup, not this meetup, from a meetup, he reached out to me with a huge project on Core ML and AR kit, and he was not able to fix the memory leak. And I took so many days to just figure it out, and it was like a nightmare to find out where has things gone wrong. But what I would say is the inherent nature of Swift UI and Combine that has, of course, we have lots of structs and more structs in Swift UI, but there are some like use cases, right? Like environment objects, published properties, actors, your observables. So whatever, when these things start coming into picture, uh, you have to make sure you understand what these contexts are doing, right? So if you are taking an environment object and you are storing everything, the whole app inside your environment object, then it's not going to get deallocated, right? But this is so hidden because it's an environment object. You don't know if it's a shared instance or it's a static or it's a dynamic. So these things come into play when you are working with SwiftUI. So SwiftUI and Combine, I should say. So trying to understand more about these annotations will help you to work through your Swift UI and memory management throughout Combine and Swift UI.
Yeah. I think one of the other things that we need to understand from SwiftUI, and a bit of hint was thrown from Shubham, was internally it uses reference types only, right? And just think about it. Like we always hear this thing that view structures are tree based, right? Like one node and the other node, and that is how the entire environment object construct gets propagated across the child system, right? For example, you define from one node an environment object that is accessible to the child nodes of the others. It will not be accessible to the other, unlinked nodes of views altogether. So how would even a tree-based construct come into place if it's not reference type? So internally it uses reference type. And if you go back to the errors that you were seeing earlier, right, in the primitive ages of SwiftUI, you would see a lot of these errors coming as a auto layout errors altogether, right? So there you can see that internally a lot of views also use UIKit constructs internally. Though that would be definitely changed when you go ahead forward, but there is definitely references that come into play over here. Yeah, Shubham, you wanted to say something.
Oh, please go on. That's it.
Okay, great. Yeah. So definitely ARCs play in the background, and we don't need to do ARC or anything explicit handling to ARC. I think back from those Objective-C eras where we had to manually say that, hey, just uh, deallog this, right? Release this object at this point of time. So yeah, so I think just understanding the basics of it should be great for us. I think this is something which I would say Shubham is to attend this question to. Shubham, how do you control the implicit animations in SwiftUI?
I would like to know, like, yeah, what are we meaning by implicit animations? Are we like trying to use a modifier, or is it the one which navigation stack puts automatically? Is this the one? Like, if you could get more some insight, because see, implicit animation, like if you are using the animation modifier with a say any view, then you'll have to basically provide a value with which it should react to changes. So the animation modifier, how it works is that you'll pass a modifier animation type, say ease and smooth or something, which was the like this was the default till iOS 14. So what used to happen was any of the published variable used to get an update, right? It tried to refresh the whole view and it tried to do the animation on every refresh throughout the view. So what they have introduced since iOS 15 is that they have provided a value type. So with the animation modifier, they have a new value type modifier which conforms to equitable, in which you can specifically like pass in a variable or an array of variables through which the animations should reflect. Like if you have a simple state modifier saying view appeared, and you want to do some animation only when the view appears, so you can have an on appear block. You can do the view appear dot toggle, which will set it to true. And because your any say you have some text property which has an animation modifier and its value is set to view appeared, so the animation will only be applied whenever view appeared's value is toggled. So that's how you can control the implicit animations. You can have an array of same data types as well. Say you have view appeared, say have is loading if you're trying to search something, is searching. So whenever the value of those state variables or published variable changes, then your view itself can be reloaded and the animation can be applied. So that's one way to control the animation. Another way would be to use explicit animations. You can use the with animation block, and you can have like specific state variable properties. Say you have a text, so you can have a published or a state variable saying text opacity or something, and then you can use a with animation block and manually change the opacity to 1 within the block. So again, it will only be applied to that single view itself. So two ways of doing things. I think, yeah, still like they have introduced lots more iOS 17, 18 things, which I think maybe we'll cover later. But yeah, that's how you will do it. You'll have to use the value property of the animation modifier.
Yeah. So Ratnesh, does that answer your question?
Hello, can you hear me?
Yeah.
Yeah, so like for example, you have some by default like system components with implicit animation like UI switch, right? Yeah, so and some other components also that they have some default animation inbuilt, and you are using those components with some your custom components in which you are also providing some animations. So if you change controls animation for other parts, so the system one will also animate, or you animate the like change the value for the system components. It will also allow like animate the other parts that shouldn't be animated. I mean by implicit by that with the one state change, some default animation will be triggered, but that will also trigger the animation to the parts which shouldn't be animated.
Like if you're just having like a toggle switch, right? Toggle switch anyway has an on and off. So how is it like affecting the other animations is what I'm trying to visualize it, not getting a clear idea on what you're
Okay,
asking.
yeah. So yeah, I think I couldn't explain it. Yeah. So I'll try one more time. Uh, let's say you have a UI slider. Okay, and by default it doesn't have any animation, so you can just pick and drag.
Okay.
Okay, and yeah, so when you are changing the, if you provide the binding with dot animation the value, the animation function and the value that value is coming from the binding, and you are
Correct.
using that state to other parts. For example, you say label. Okay, so whenever that value is changing from that binding, it will be changed with the animation because you have applied the animation to the binding. So some other parts that are also like shouldn't be animated are animating. Yeah, I must like I can yeah, example would be better, but I
Well,
cannot.
a visual example would be better, but yeah, like got the idea. So if you're trying to like pass in the whole property in the with animation block, right? Then you can simply not like maybe not have a define a simple animation modifier on top of the views which you don't want to animate. So in which you can pass in dot none, so that whenever you are changing your value with the slider, it doesn't affect the views in which you don't want animation to occur, which are still using the same slider value. So you can just use the animation modifier, pass in dot none, and then use the value of the same slider value. So even if you're using implicit animation block with animation, you can have an animation modifier and the pass dot none. I think that this will help you. So for ones which you don't need, you can just use dot none or dot default.
Yeah, and like my particular example, deals with the transition animation, because when the view is not appearing, not in the render tree, then like some of the parts are getting animated and some of the part are not animated. So my question is more specific to the transition animations. Sorry about that. I didn't mention.
Got it. See, I've had issues with transition. Like if you use view inside a navigation stack, sometimes the view keeps jumping. I've faced that problem, so I usually just use the hide navigation bar modifier itself to hide it. But okay, well, once you have a UI reference, I'll be able to understand better. Maybe we can connect later.
Sure, thanks.
Cool. I think we have a couple of questions, but let me try to group it and probably just try to discuss on a common section as topic, right? Because we are already a bit of out of time. And to be honest, I don't want you guys to spend a lot of time out of this meeting, right? And also, like, we have lended Shubham's and Pran's time for this thing. So yeah, so Shubham, I think, and Pran, let us discuss two different sections. The first is around navigation, right? I think we have seen a bit of questions around navigation and also around coordinator architectures and stuff, right? And why do I want to take it together? Because I think coordinator is basically a design pattern to manage navigations, right? How efficiently we manage navigation across. So let us discuss how navigation, right? Because we also touched that topic a bit earlier as well. And what differentiates between UiKit and SwiftUI on a larger scale is the maturity of navigation as of now, right? If you're handling deep links, if you're handling what do you say, complex navigations, then probably you have to what do you say, like get into UiKit backing as your navigation mechanism, right? So let us start with navigation and discuss navigation a bit around how it is currently with SwiftUI. What are the current problems, right? And how do you approach if you want to fix it with going with a pure SwiftUI mechanism, or you want to go with the old school UiKit navigation plus SwiftUI as layers, right? So let us try to understand the current state of things and what are the issues that can come up that people should be aware of before choosing what sort of navigation that they want to get into. Yeah, anyone, Fran, you want to go ahead?
So I have not played around a lot with Swift UI's navigation and tried to see where it goes messy. But I would like Shubham to answer this. How does this navigation thing works in Swift UI?
Yeah, I think
for UiKit I can
right.
can comment. Yeah.
Yeah,
So UiKit is something that how to say, for me, if you even turn off the internet, I can fix a UiKit issue. So if there is anything, I am confident that I can fix it. But when it comes to SwiftUI, I have to like Google around, ChatGPT around. So that's the main thing, right? When it comes to controls over animations or transitions, so even if you go for a very complex transition, I would say, which where you would enable user to continue his touch or responding to touch during the animation. So that sort of thing, I would consider it as a complex use case. So yes, that is very possible with UiKit, and that's what UiKit was meant for, to go to the deepest level, and then if you want to tinker around with any setting, you could always do that, right?
Gotcha. I think let us hear from Shubham. Like Shubham, if you can throw some light around what do you say, the SwiftUI navigation system versus UiKit, and then I think we can circle back to Pran to understand his takes after hearing your thoughts on both SwiftUI and UiKit.
Navigation has been messy in the SwiftUI, to say the least, until iOS 16, I would say. So before pre-iOS 16, you'll have like different navigation links, which inside the navigation link you could provide a destination where you want to which particular view you want to redirect the user to. So it worked great on a one-to-one basis. You have view A, you want to go to view B, and it will work, say, seamlessly. If you have to go to view C, then you'll have to actually start injecting some hacks into it. So which they tried solving at navigation stack. So navigation stack is there since iOS 15. So they tried a couple of ideas. Even with the help of navigation stack in iOS 15, you still have to create different navigation link inside navigation view so that it will take care of whether you want to go from A to B or you want to go to B to C. With the advent of iOS 16, it's become a much more easier to navigate. So you have something called navigation destination. So what you can do is you can create an enum which conforms to a hashable protocol, inside which you can basically provide all your navigation destinations as a enum case, like home, landing, login, onboarding, so on and so forth. And then you can have a single navigation stack inside which you can just use the navigation destination for modifier, passing the hashable. Inside each of the hashable, you can just use a switch case with an inside the enum, in the same enum, and you can just provide singlistic views. Okay, if my current state is onboarding, I'll show onboarding view. If my state is login, I'll go to login, sign up. So that thing, say all the different navigation flows are controlled within a single navigation destination, which is like amazing, and I've been loving it. Still, for complex projects, I'll still like prefer to go with a UIKit based approach. I usually end up creating a single router class, and I'll then use the coordinator pattern so that be any any major pushes, like I'm going from login to say a home screen, I'll just use that particular coordinator to push the home screen. Now within, I've still like had some scenarios in which I still ended up relying on both navigation controller and navigation stack. Assume from home screen you're going to a settings screen. Now inside settings you again have lot, and your settings screen is basically created with SwiftUI. Inside settings you might have like different sections of different settings. For navigating that, you can again easily go on and use navigation controller to post a different screen. But because settings is a single module, or say it's something which is created with SwiftUI, then it's better to go ahead with a navigation destination, and whatever setting related screens are there, you can easily provide all of them in the navigation destination, and then use SwiftUI internally in the single screen wise level. And when you actually pop back from the settings, you can again come back to your router based approach, which is much more reliable in terms of, yeah, as Pran said, keen better, much more better in terms of handling deep links, handling every specific edge cases. Suppose you have to log out the user if their access token is expired and all. So I'll like still go ahead with the router based approach with the UIKit.
Yeah. So Pran, with hearing all of these things, right? So what would you think about, what do you say, the navigation things, right?
So I've not played around with navigation in SwiftUI much, but still I would say that based on my experience, nothing is impossible for any framework. Uh, if Apple develops a framework or a stack, it's definitely well thought, at least use cases. So something cannot be impossible. But yeah, that's where the tech stack choice comes through, right? That X task in this tech stack is easier, and in Y tech stack is a bit more difficult, right? So there is your choice where you have to decide what's your use case and what's your solution for your tech stack, right? So if Swift UI easily solves your case, like taking up small views and then just having it as a reusable component across all your platforms, yes, go for it. But if your use case is something that you would like to write up a lot of code than you actually want to with Swift UI, then it's better to go for a UI.
Right. Greatly said. I think, yeah, that makes sense. So one thing that I just also wanted to share over here is that uh, I think what we need to understand as programmers is that we need to follow the basic principles of programming, right? If we just follow simple constructs such as solid principles and reusability and other different design patterns, I think we'll be able to solve a lot of different things at our end, right? So, for example, think about like if you're wanting to use coordinator based design pattern as of now, because we're really not sure enough that how our app would scale and what extent it would reach. So let me just go ahead and fall back to the navigation that UIKit has, right? But if you're keeping your navigation very separate from your view layers, then it would be eventually very easy for you to convert it to SwiftUI if the time comes, right? And that is where I think we need to take a stand on what we do. Because if you look back into the architectures that we had back then using UIKit or anything else, right? We had coordinators, we had Redux-based architectures, right? Like which are like more state-based architecture. The modern form of it is like the composables that you see for SwiftUI. You have MVVMs, MVIs, MVPs, and whatnot, right? And all of this have actually solved this problem to isolate certain use cases, be it business logic, be it UI, be it networking or something else, right? And that actually helps you to migrate to a different other layer very quickly, right? So when I gave this example of Uber using Riblet, which is very, very inspired from Viper, for them migrating to a certain new architecture of SwiftUI wouldn't be that difficult because their logics are very separated, right? Because if you say like if you have really done MVVM in the right way and changing that MVVM to a SwiftUI based MVVM, or sorry, a SwiftUI based MVVM or a view model wouldn't be that difficult, right? And I myself have refactored a couple of my projects into SwiftUI, like in my current organization, one of these parallel projects that I had. And from my experience, what I say is that once you click all this design and programming guidelines correctly, then you will be able to migrate and navigate in all other scenarios, right? So be it like SwiftUI, be it UiKit, or be it some XUI that comes in by Apple, the upcoming future, right? So yeah. Thanks, Pran. Thanks, Subham. I think with the best interest of time, I would say that we'll move to the next section. Thank you so much for sharing your inputs. And I think Nayan has already shared a WhatsApp chat invite link. So, folks, I know like you have some generic questions, but I'll just take one more generic questions, guys. Right? Let's spend some 5 odd minutes and hear out from Shubham and Pran again. Right? I think Pran has been there in this industry from quite some time. Shubham has seen like how these new trends are coming up, right? So let us understand that how the job market has changed. What is the current market condition? And how folks joining in new to IT and new to this mobile industry can cope up, can sort of deal with this market volatility and probably strike a new job, right? Let us share your thoughts, right, Shubham and Pran. What do you think about the current job? What is your advice to the freshers, right? How they can keep themselves updated, how they can grab a new opportunity and these things, right? I know like what is it? This is a very, very confusing and concerning topics from very other many other folks that we have seen across. So I would like to take this discussions as one of the confusing uh, statements from you guys, right? Around your experiences, your suggestions to juniors and like-minded colleagues. Yeah, please.
Okay, so I'll start. So I think the scenario for hiring and getting like the hiring and the iOS role has changed quite a lot since the COVID times. So nowadays I've seen companies much more like tend into much more into like the actual practical skills instead of going for a theory based approach. So I think first thing would be to like clear out your fundamentals, like have a good understanding of Swift programming language. Have a one because that this is the base of all of it. Be whether you choose to go with a UiKit based approach or if you want to go with a Swift UI based approach, Swift is at the base of it. So first of all, it definitely is like having a good solid understanding of Swift programming language. Second would be to again have a decent understanding of networking, how to call different kinds of APIs, how to basically implement a scalable network layer so that you can incorporate third party or maybe some certain same sets of APIs with the same base URL. Then you have your protocols. Again, it will tie up with saying like Swift as well, but I'm still mentioning it because you can actually like showcase your understanding of things by dividing big problem statements with the help of protocols. Then you have databases. I think it's better if you like familiarize yourself with core data, at least the basic CRUD functions, how it works. And then you have your architecture. Again, architecture maybe you already had a talk, even Prahan gave his insight. So it's something which you'll only get by practice. So I think if you're trying to look for a job and if you're saying like, definitely the number of jobs are less and it's extremely hard to get a new job as a fresher. So I just say that pick a small project and get some hands-on into it, because by like working on your own hands-on project, right, you'll obviously get stuck and it will be challenging at first, but solving like whenever you get stuck, then that is when your mind will actually start to think about the problem. Okay, how do I solve it? What does Swift or UiKit or Swift UI framework provides that will help me to solve it? And you'll gain actual building skills. So what will happen is that whenever you go for any interview and such, because you have that hands-on experience to face a problem, to figure out different approaches and to pick a valid or easy to implement solution, that is when you'll actually be able to like showcase that you actually have a good hands-on problem solving skills, and whatever problem they throw at you, and you can actually at least figure out what are the complexities or the edge cases that you can think of, and two three solutions, and being able to like pick the most optimized one. So I think building, I would still suggest that key build small apps, build apps like calculator, build a replica of apps that interest you, any app, and just go from there. Like once you are actually able to implement all the features that you actually thought of, okay, I'm making a calculator app, I'll have a basic calculator operations and I'll have scientific calculator operations. Once you're able to achieve it, you'll have definitely learned a lot, and you'll also be able to like figure out and understand ki, okay, these are the pitfalls that you actually have to think about when going about a new app. And it will also definitely speed up your speed of execution as well. Given a new project, you will be able to quickly understand ki, okay, this is how my base structure and the base architecture should look like, and now on top of it I can use anything. I can maybe use a UI kit or SwiftUI. At least once my base is solid, you can do a mix and match and things like that.
Yeah, thanks, Shubham, so much for that input. How about you, Brand? Would be your suggestion to what do you say, engineers across newer generation, mid, older, right?
So right now, I am a lead at my company, and we have some we have folks who are starting fresh in an iOS. So what I say them is I share my experience, how I started and how I came here. What I am right now is during my fresher days, what I used to do is I worked on my own project, but at the same time, I was in a service-based company and I had a lucky group. So I used to help my teammates who are working in other projects wherever they are stuck, and that's where my journey scaled up and my knowledge scaled up. Where someone is working on, let's say, some map, someone is working on, let's say, some CI/CD based solution or issue, or someone is working on X thing, X amount of, or someone is working on core data and things like that, and someone is working on some crazy multi-threading stuff which they have. So right, so it's really hard to get an opportunity to learn a variety of things in one particular project. This is where communities like our one, Swift Bangalore, or following people like Shubham, they are like constantly giving you materials and things to think differently. Try to understand your affinity, which topics or which things makes you feel most excited and energetic. Because after working or after doing through your project, you are drained out and you need a lot of energy to cope up with multiple things at a time, to build up a portfolio or to crack that interview or to get knowledge, at least working knowledge around multiple things. So that would I suggest most to start solving problems, be it in terms of projects, as I have highlighted in one of Shubham's posts where he has listed so many good starting projects, right? So these are the things that choose your forte. If building sample projects makes you more excited, start with that. If not projects, but solving actual real people problem, that makes you more excited and energetic, go with that. But yeah, try to solve a different approach, because it's really hard to get a solid and a broader overview in one single project, in one thing at a time, right? So try to gain some depth and breadth with this approach.
Yeah. Thanks, Brand. I think the takeaway over here for all of us is like with this market, we need to keep ourselves updated, right? And we need to figure out ways in which we can keep ourselves updated and we can share our learnings and our doings across. Earlier, it was blog post. Now you have more advanced forms of things like take, for example, like how Shubham is doing, right? He's sharing those animation videos and things across, right? Which is helping him to get connected with different folks, right? To build his networking. So that would help eventually, right, in long run to help you get more and more opportunities to connect you with more and more folks across, right? So we have to figure out such things. And primarily, why is he doing? He's doing out of his own interest, out of his own interest in learning and probably doing the activity that he loves most, right? And that is where I think we need to focus most. That we need to figure out that why we're doing this job, right? And I think that is the biggest motivator of all. And the motivation is something that we have to keep taking even in this, what do you say, in this volatile market, right? So with that, I would just extend my thanks to Brian and Shubham for sharing all their inputs and all their thoughts and being with us over here again. So thank you, folks. Thank you so much. So moving on to the next thing, I'll just share and probably extend some thanks to the core team behind the entire arrangement. So this is the core team that you're seeing of Swift Bengaluru. So we have Amit, Nayan, Kriti Priya, myself, Gokul, and Sabapathy. So Sabapathy and Nayan are currently right now with us. We have joined. I don't see other folks, but yeah. So these folks have been part of all these efforts that we put in, like bringing this meetup group together and performing our activities. So the other contributors that you can see are over here, right? You can see here different other names. So there are many folks who have been associated with us from quite some time now, over various years, because Swift Bengaluru has been active since 2014, right? And I think Nayan over here is there with us and has been driving all of the group's initiative from back 2014 days, right? So yeah, so here are the community contributors, and we have sort of what you say, different other parallel tracks, right? Where we look always for volunteers, right? So if you want to volunteer yourself, please do reach out to us. You can just DM us over LinkedIn, right? We'll be responding to you. And we are also continuously looking for venue sponsors, right? Although we acknowledge the reach of online meetups, right? And how we can connect across boundaries, across time zones, we still also value that folks who can also connect physically with each other, right? And if we get a chance to meet wonderful folks like Pran and Shubham, right, physically, and learn from them, it would be really very, very amazing for us, right? So you're consistently looking for venues, and if you can help us get a venue from your organizations or for some other organizations, we'll be really, really grateful. So that is one thing. Then we also do have what do you say, a parallel track to contribute into Swift open source. If you are really interested on understanding how to and where to start with Swift open source, then I think you can also do reach out to us. With that, I would also like to sort of what you say, take your attention to the chat messages that we have. I have just shared a link, right, where you can actually share your feedbacks, and that would help us improve. And I'm just resharing that again so that I would just pop up that in the recent of your chat messages. So please do share your feedback as we just go ahead and try to wrap the meeting up. And again, so I think this is all about venue sponsors, right? So if you come across any sort of possible sponsors, then do let us know. Let us know via LinkedIn or probably other means of channel. And yeah, I would now go back and probably what do you say, like stop sharing. And I would like all of you folks to probably turn on your cameras. I'll just probably give some 20-30 odd seconds so that you can take your time, just brush up yourself, take some makeup, and probably turn on your cameras if you can. We'll take a nice small snap so that we can share it across with folks. Yeah. Folks, please don't feel shy. If you can turn on your cameras, then please do turn on your cameras, right? Would like to take a snap. Yeah. Thanks, Naresh. This is very anxious. Like, am I looking right? Yeah. Yeah. I can see Rashid. I can see Yogesh, Avan. Cool. So yeah, I can see Shashank as well. Hi, folks. Yeah, I can see Thamurai. Yeah. Hey, Moksha. Yeah, yeah, great, great, great. Thank you so much, guys, for turning on your cameras. Let me quickly take a snap. Yeah. did have one. Let me take another. Thank you so much, guys. I think you are the ones who actually make this work, make this event successful, right? So let me just move to the next slide of our presentation. Yeah. So yeah, with this, I would once again thank Sabapathy, right, for his wonderful talk in Async, Await, and Swift Concurrency. I'll extend my thanks to Pran. Thanks, Pran, for being with us, right, being as a part of this community and sparing your time to discuss a lot of these things and answering questions of folks over in this weekend. Thank you, Shubham. Thank you, Shubham, for taking your time out from your wonderful animations world and jumping over here in your spare time to share your experiences. Yeah, guys, yeah, Shubham, you wanted to say something?
Oh, just saying, Kate, thanks for having me here. Like, it's great to actually like connect with all of you guys and give something back. I've been thinking what else I could do, but I'll definitely reach out to you again. I have some ideas.
Great.
Yeah, I think it's great to like get the community involved, and I see lots of people actually like coming in with great questions and give us an opportunity to at least share our experiences. So I think I will connect and we'll come up with something cool.
Thank you. Thank you.
Overall, it was like
Uh,
great.
Thank
yeah,
you. Thanks a lot, guys.
thank you, Brand. I think we are looking for such ideas and we're looking for all of the smart folks who have joined with us to connect and make these events more successful. Thank you so
Yeah.
much, guys. Please do fill the feedback form. It really helps us improving the format of this entire meetup. So, yeah, thank you so much. I'll just pause here for what do you say, 30 more odd seconds till I wrap this up. And please fill your feedbacks till then.
Thank you.
Cool. Thank you so much, guys. Thank you everyone for attending. Have a great day. Have a great weekend. Yeah. Bye-bye.
Thanks, guys. Bye bye.
Thanks. Bye, everyone. Thanks, Subham. Thanks, Brian.